Okay, so today we're going to talk about exponential and binomial distribution, which really isn't that bad. Another little tedious part, well actually it's a really big tedious part, but not that bad. Okay, so let's just look at an example to get kind of the big idea. So do you guys recognize this is exponential? Yeah. Hence the E, right? So you don't need to write all this down right now. Let's just look at it to get the big idea. The average length of time that a student at East High School spends talking on the phone per day is 1 hour. What is the probability that a random chosen student talks on the phone for more than 2 hours? So do you notice that it starts probability, it starts at 0 and goes all the way to 1? So for instance, this would be 50%, 60%, 70%, all the way to 100%. So the student that spends an hour on a day would be right here. So 40% of students spend an hour a day. It says, what is the probability that a randomly chosen student talks on the phone for more than 2 hours? That would be us looking at this group of students here. Get the idea? Okay. So in this equation here, M stands for, it's kind of long, this is all you need to write down right here. This is the multiplicative, no, 8. Multiplicative inverse of the mean. And x is your domain value, usually time. I'll let you write that down. Recording. So our learning objective today is I'll be able to use exponential and binomial distributions to find probability. You should be able to explain when a distribution is exponential and when it's binomial. Sounds a lot more complicated than it is. Okay, so exponential and binomial distribution. I thought you guys would like that. The average amount of time a North High School student spends studying for a math test is 45 minutes. You don't need to write all this down. Just write the pieces of information that I'm going to give you. So I said the mean. The mean is how long? 45 minutes. So then what would be the inverse of the mean? Multiplicative inverse. 1/45. What is the probability that a randomly chosen student studies for longer, that's key right now, longer than 120 minutes? Okay, so anything that's longer is, we use this formula, f of x equals e to the negative mx. So f of what? How much are we talking? 120 minutes would equal e to the negative 1/45 times 120, which is e to the negative, this is how I put it in my calculator, 120/45. And you should get about 0.07 or a 7% chance. So put that in your calculator, make sure that that's what you get. All right, let's go back and talk about the reasonableness of this. Is a 7% chance reasonable if we're talking the average is 45 minutes? Yeah. So those that are spending 120 minutes, they would be a small percent, right? Yeah. Okay. So if blank CDRs last an average of 5 years, so my average is how much? 5 years. So what would be my multiplicative inverse? 1/5. What is the probability that a randomly selected CDR will last less than a year? What do we normally do when we find something that's less subtract. So you're going to use the same formula, only you're going to take 1 and subtract. Kind of like taking 100% and subtracting. 1 minus e to the negative mx. You see the difference? More, regular formula. Less is like the inverse, taking 100% and subtracting. Make sense? So this would be, what's the time period? F of what? 1 equals 1 minus e to the negative 1/5 times 1. Put that in a calculator, and you get about 0.18126, or 18.13% chance. Does 18% make sense? Average is 5 years, so how many would be less than 1 year? 18%. Give you guys a second to write that. All right, let's move on. A candy company. Okay, put your pencils down and just kick back for a minute. A candy company produces bags of strawberry and vanilla flavored candies, 65% of which are strawberry on average. You got a bunch of candies, right? Strawberry and vanilla. The probability that they're strawberry is about 65%, right? Or on average, 65% of them are strawberry. Get it? How many candies do you think they have in the factory before they put them in a bag? A lot. So 65% of them on average are strawberry. What is the probability that if you had a bag of 10 candies, at least 4 of them would be strawberry? So, does this look familiar? Combination?
Yes.
So, it would be a combination out of 10 candies. How many? 4. But it says at least 4. I'm going to come back to this on what these things mean in a second. Well, we'll just say these are your successes. So you've got, the number would be 10, choose 4, right? This is your probability of successes. And this one would be your probability of failure. So, it asks me for the probability of what? At least 4 strawberry. Okay, I told you guys to kick back. Right? I'm going to give you time to write all this down. It's going to get hairy. So the probability of at least 4 is the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10, right? Because 4 or 5 or 6 or 7 or 8 or 9 or 10. Correct? Or, that's a lot of probabilities to find. Wouldn't it also be easier? What does all probability add up to? 100% or 1.0? So couldn't you do 1 minus probability of 0, minus probability of 1, minus probability of 2, minus probability of 3? Isn't that the same thing? If you add up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all those probabilities, what is it going to add up to? 100%, or 1.0. So you could either find 4, 5, 6, 7, 8, 9, 10, or you could find 1 minus only 4 of them. Let me say it a different way. There are, it's the inverse. There are 1,000 pennies in this huge, like one of those big Sparklets bottles. There's 1,000 pennies in there, right? I don't want to count 1,000 pennies. So I put them, like I think I put them evenly in jars, in 10 jars. Would you rather count 6 jars of pennies? Or would you rather say there's 1,000 minus 4 jars of pennies?
1,000 minus 4. Right?
But would you rather count 6 jars to find how much was in 4? Or would you rather take 1,000 and subtract 4 of the jars to know how much is in the 6?
Wouldn't you have to add both the 4 and
The 6 to make 1,000. Yes, Evan.
For that example, wouldn't you have to know how many are in each one for each jar?
You would count them. Would you rather count 6 or would you rather count 4?
Oh, because you think.
You see what I'm saying?
Yeah.
The penny example doesn't really follow as well. I'm just trying to like give you another idea of it's easier to count 4 than it is to count 6. And if it's all going to add up to 100% anyways, wouldn't you rather find the smaller amount and subtract than find all? You're more than welcome to find the probability. Let me just give you a visual here, okay? And then it might clear things up. So to find the probability of 4, I'm going to do that over here on the side really, really quick. Probability of 4 would be.
Oh, wait a minute. Yes, so everyone after that one.
Yes.
I didn't know.
Can we stop complaining? So probability of 4 would be combination. 10 choose how many? 4 times the probability of success, which is 65%, to the 4th power. That's how many successes I have, 4, right? Times the probability of failures, which is 35%, to the 6th power. There's probability of 4. Then you got to find probability of 5, 6, 7, 8, 9, and 10.
Okay, no.
Or,
4.
so do you see the need to find an easier way?
Yes.
Hence, I'd rather do 1 minus 4 of them than have to add 6 of them together.
Let me.
Yes, sir. Yes. Yes. If it was at least 6, you would only do 6, 7, 8, 9, 10. You wouldn't do 1 minus 0, 1, 2, 3, 4, 5. You know what I mean? If I said at least 9, wouldn't you just find 9 and 10?
Oh,
How do you know that would be other?
Yeah.
So it always is.
It said it's 10. Okay, yes, Brian.
No way to explain it. You know, if someone gave you 10 Pepsi soda to try, and you only liked 3, and you didn't like 7 in math, which one you didn't like, it's easier to say that you like.
Oh, I like that. It would be easier to say the 3 you did like rather than say the 7 you don't. Good job, Brian. See what he did there? Okay.
are they always going to be the down numbers? There's no
No.
guarantee that.
No, they're going to be like decimal. Like this.
Yeah, there's no guarantee. Okay, so let's get to work. I wanted it to be in black. Okay, so I would say 1 minus probability of 0 would be C, 10 choose 0, 0.65 to the 0. Remember on the binomial theorem, if we had 5 factorial, 3 factorial, what would this be? 2 factorial. It's the same thing. If this is 0, then the failure has to be 10, because 10 and 0 have to add up to 10. Got it?
Yes.
Minus C, 10 choose how many? 1. Therefore, this one's going to be 1, and this one's going to be 9. This is 0.65. This is 35. Minus C, 10 choose 2. 0.65 to the 2. 0.35 to the 8. Minus C, 10 choose 3. Are you guys having fun yet? 0.65 cubed. 0.35 to the 7.
Yeah.
That's the probability.
Oh.
So if it's 65% is a success rate, then the failure rate is the other part of 100%, which would be 35%. Okay? So go ahead and write that down.
Yeah.
And if you were to put that in a calculator, you would get success. 0.9747 or a 97.47% chance. Does that make sense? A 97% chance that if you were to pick, if you had a bag of 10, there would be 4 or more strawberry in there? That makes a lot of sense. What did they say what was the average strawberry in the company? 65%. So wouldn't you expect there to be 4 candies in there? At least 4, right? I would expect there to be 6.5 to be exact, right? So on average, the probability of somebody getting 4 candies out of 10 is at least 97%. Any more questions? Does it make sense? Is it fun? No. Does it make sense? Yes. All right, so a candy company produces bags of strawberry and vanilla flavored candies. Evan, if you're paying attention, there you go, 3B, because we're still talking about the same thing. So if they told us 65% are going to be strawberry on average, what's the expected number of strawberry candies in a bag, Ryan?
Depends on how many are in the bag.
No, 10.
10 are in the bag.
10. It says 10 are in the bag. It would be 6.5. Then there would be 65, right? Expected. We would expect to see them. Can I get you guys to stop talking? So the way you find the expected value is exactly what we did in our heads already, right? If there's 10 candies in a bag, well, I know I've got 65% of 10 is 6.5. The number of candies. It should be an N in there, like they should match, but it doesn't. This is how they write it in the book. Okay? I don't like it either, but you know what? We're not married to it.
Can we change it?
Sure.
Write a letter.
It's yours.
No, it's terrible.
So there's 6.5 expected candies. 6.5. It would be 6.5. I know what you're saying. I get it. But we're talking probability and expected values. If you're trying to be accurate, you would say you would expect to see 6.5.
That's it?
Yep, that's it. Yes. No. No, it would not technically be 7. It would be 6.5.
You would literally get half of vanilla mixed with the strawberries.
Yep.
That is what you would expect to see.
That's what you would expect if it was 65%. If somebody told you there are 65% strawberry inside of that box of 10, you would expect to see 6.5.
You have to think about this.
It's completely literally. But I like the way you guys are thinking.
So I was going to say, like, it's like you're not going to get something. Like 2 lows on the trade.
But you are just estimating. We don't want an estimation. We want exact. All right, 5, 4, 3, 2, 1. I need it quiet. We're not going to do this because I just want to take questions. Even though, look at cute little ant.
Cute little ant.
Okay. So what did you learn today?
Oh my God.
Perfect. Good. Guys, I need you to freeze. We concentrate on success and failures in what type of distribution?
Exponential?
No. Binomial. Remember, the exponential was the easy one. Here, this is your guys' over here. So write the two formulas for an exponential distribution and label their components. What are the two exponential ones?
F of x equals e minus.
But don't give me the formulas. What are they? One is if we're
One more than.
and one is less than. Good. But I need you to write them. One is more than, one is less than.
Oh, wait, so we just can't write one more than one.
No. Yes. Yes. Right, which one's more than, write that formula, right, which one's less than, write that formula, and then like draw little arrows that say what each thing means. Make sense?
And that'll be the minus.
Yes. Good job.